Hey everyone, I'm back with a new video. I'm Varsha. Today's topic is on theory of computation. The opacity of timed automata. This overview explores the concept of opacity in context of timed automata, a formal model used to represent systems with timing constraints. We will delve into the challenge of verifying the opacity and its practical applications in various domains. Introduction to timed automata. Timed automata are mathematical model used to represent systems with timing constraints. They extend classical finite state automata with real valued clocks that can be used to reason about timing behavior of the system. Timing constants. Timed automata allow the specification of timing constants such as minimum or maximum time required for transition to occur. This enables modeling of real-time system with precision. Applications. Timed automata finds application in areas like scheduling, network protocols, and safety crucial system where timing is crucial factor in correct operations of the system. Defining opacity in timed automata. Opacity concept is a security property that ensures confidentiality of sensitive information in a system. In timed system, opacity considers the timing behavior of the system, whether an observer can refer the sensitive information from the observed actions. Timed opacity. Timed opacity extends the classical opacity definition to incorporate timing constraints. It aims to prevent the observer from deducing sensitive information based on the timing of the events of in timed event. Application scenario. Timed opacity is practically relevant in areas like cyber physical system where a timing of an event can reveal the sensitive information about the system's initial state or operation. Verification of challenges. Verifying opacity in timed auto system is a complex task due to added timing constraints and the need and the behavior of the system over time. Approaches to verify the opacity. Model checking. One approach used to model checking technique to verify the opacity property by exploring the state space of timed automata model. Synthesis. Another method is synthesize or a controller that enforces opacity by restricting the system's behavior only to include opaque extensions. Abstraction. Abstraction technique can also be employed to simply timed automata model and make opacity verification more trackable. Complexity of opaque verification. I complexity. Verifying opacity in timed automata is conceptually complex problem, often requiring exponential time and space complexity. Undecidability. In certain cases, opacity verification problem for timed automata has been proven to be undecidable, posing significant challenges for practical applications. Restricting up and approximations. Researchers have explored various restrictions and approximations. The opacity verification problem is more trackable but on ongoing research. Enforcement of opacity in timed automata. Supervisory control. One approach to enforce the opacity is used to supervisory control techniques to restriction the behaviors of timed automata model to include opaque extension. Dynamic opacity. Another method is to induce the dynamic opacity where system can adopt its behavior at runtime to ensure sensitive information is not revealed. Modular approaches. Researchers have explored modular approaches that combine different techniques to enforce opacity in scalable and efficient manner. Applications of opacity in timed system. Cybersecurity. Opacity can help to protect the sensitive information in cyber physical systems where timing of the event can be exploited by adversaries. Healthcare opacity can be used to ensure patient privacy and confidentiality in medical devices and systems by offering timed constraints. Industrial automation opacity can be applied to protect the intellectual property and sensitive manufacturing processes in the industry automation system. Aerospace opacity can be imagined as safeguard the sensitive information in aerospace systems such as satellite instability. Challenges and limitations. Complexity challenges. High computational complexity of opacity verification in timed automata poses significant challenges for practical implementation, especially in large scale systems. Timing constraints. Incorporating timing constraints into the opacity definitions and verification processes adds an extra layer of complexity that must be carefully addressed. Modeling limitations. The expressiveness of timed automata may capture all the nuances of the real world, requiring exploration of alternative modeling approaches. Recent development and research directions. Abstraction technique. Researchers are exploring advanced abstraction method to simply timed automata models to make opacity verification more trackable. Approximate verification of developing approximate verification algorithm that can provide a probabilistic guarantee or bounce error results. Hybrid approaches combining of different techniques such as model checking, synthesized learning to leverage the strength and outcomes of an individual limitation. Timed opacity metrics, defining and analyzing the metrics to better understanding the information leakage. Conclusion and future work. The study of opacity in timed automata is an active and challenging area of the research with numerous applications in security crucial systems such as the field continues to evolve. Researchers are exploring innovative techniques to address the complexities and limitations, paving the way for more robust and practical systems.